In this video, we're going to explore doing some pipe flow calculations. Now, typically there are two ways that we're going to compute flow in a pipe. Now, one method is where we're only going to have the depth of the water in that specific pipe. And that's going to be good when we're going to have a long, steady pipe where we're going to be able to use a derivative of Manning's equation to actually compute the flow in that pipe using things like the geometry of the pipe and the roughness of the internal of the pipe. Now, the other way of doing a flow calculation is actually monitoring the flow velocity, usually using an acoustic Doppler or some sort of flow velocity meter in the pipe as well. And this could be more useful when we have backflow conditions or when we have some sort of control methodology that's not strictly the pipe itself, when we don't have prism flow down the pipe. Now I'm going to start by doing the calculation using the simple Manning equation using prism flow down that pipe. And to do that, we're going to use the math and statistics roll-up, and in here we have a custom toolbox. Now this custom toolbox, if I drag this out and I select from the custom toolboxes we have installed on the system, non-pressurized gravity pipe flow. Now this would be typical for something like combined sewer flow, for example. Now I'm going to go to the properties of this specific plug-in toolbox, and we're going to see a few things pop up here in terms of the units we're going to need to deal with. So either we're dealing with metric or English units. That would be the US customary units. In this case, we're going to be dealing with English units. So I'm going to click to use English units. That's going to affect the constant in Manning's equation. Then we're going to have to enter the roughness. And just as a reference here, we took from the engineering handbook some of the roughnesses of some pretty typical pipe materials. Now this is just for pipes. When we get into stream calculations, the roughnesses can be up to 0.075, so they can get quite high. And the default roughness here is for exactly the element that I have in this case. This is a concrete pipe with steel forms. We also have to enter the pipe slope. So what is our drop in slope? So the drop in slope, or the drop in the pipe's height over the length. In this case is about 1 foot for every 1,000 feet of run. And we also have to enter the diameter of the pipe. Now this is going to be in the same units as we're dealing our input time series of depth. Now in my case I've got the depth in inches, so I'm going to enter this one, the dimensions of this pipe in inches as well. And this happens to be a 24-inch pipe, so I'm going to enter that right here as 24. We're also going to use the description in units of my output. Since my units here are all in inches, my output is going to be in cubic inches per second. So this is going to be cubic inches per second. And I could give a pipe flow. I could give it a more elaborate description if I wanted to as well. So I've just set up the properties of this calculation for myself. If I click OK and then I go to run this, the first thing I'm going to need to do actually is plug in a time series. So I actually need to click OK for now. And I want to plug in a depth time series. And this is the pipe water level. If I right click to just to quick view that data before we run the calculation, we're going to see here the water levels in my pipe. Occasionally we get up to nearly the top of the pipe. Once we go over the top, and this is actually going to be a special case of the calculation when we actually get pressurized flow. So we're going to see what happens to that in the end. It's actually going to produce non-numbers because the calculation can't be performed when the pipe is over full and is pressurized. So I'm going to wire that data into the custom toolbox. Go into the custom toolbox. We're still set up. Everything's the same. Go into the properties, check everything. Still a 24-inch pipe. Then I'm going to click to run this calculation. It's going to go away. It's going to actually run the calculation. And when we're done with that, we're going to see the output right here. This is my flow. If I quick view that, we're going to see here, this is my flow in cubic inches per second running through that pipe. And one of the things we could do now is we could grab a quick view toolbox from the visualization and reporting. Let's just grab a quick view, bring it out, and let's go to the properties pane of quick view just so we visualize two things at once here. I'm just going to enter 2 as the number of ports we have. And I'm going to wire in both the flow and I'm going to wire in the water depths. And we're going to see that one is a function of the other, obviously. And you can see here these two, the flow in cubic inches per second and also the water depth in the pipe in inches. And if we lock these two axes together and when we zoom in on one section, we're going to see how these two are related to each other. And we're also going to see when the water went over height, when we went above 24 inches. In this particular case right here, if we zoom in on it, we're going to see that there was one specific time where we went over 24 inches, and we've actually got a gap value now for our flow in that particular case. So those two are going to line up because this is actually where we want to go in and use a separate calculation and then splice these two time series together. So we're just going to zoom out on that. Now, one of the other things we may want to do is look at the relationship between these two just to check that the scatter plot is correct. And we can do that actually by going into modeling, and we can use the empirical modeling toolbox to just visualize that relationship. If we want to look at how the flow is related to the depth, just empirically, we'll just have a scatter plot of the result of Manning's equation if we go in here. Now it's just going to load up and take 1 second here to initialize the math engine. There we go. We should have things plotting up in just a second. Here we go. That's our flow in cubic inches per second, and that's our depth of the water. Now, if we just zoom in on any section here, we can select to put some training markers down. So we'll select the data we want to have a scatter plot of. And this is, of course, explained in more detail in the modeling videos. We're just going through here to look at a result. So if we choose to build or test a model in that particular section of data, it's going to grab that data. And you can see right there the relationship in between the depth of water in inches and the cubic inches per second, the flow. And you can see that exact topping off as our pipe starts to get nearly over full. We get a flattening of the relationship as the roof of the pipe, the roughness on the roof of the pipe starts to restrict our flow. And we actually see that shepherd's crook sort of shaped graph coming through. So that's one way. We're just going to look at this. In this case, we don't need to build a model or anything like that. We've already done that in the computation. That's just a bit of a visualization. We don't need to save any of that output either. So that's one way of doing this particular type of computation. Now, the other way is actually if we have the velocity. Now, in this case, we actually do have the velocity. So I'm going to quick view that. And you can see here we've got a fair amount of velocity going up and down in this pipe. So actually, the calculation that we did just do is probably not appropriate for this case because we obviously have our flow here in inches per second not being correctly we don't have a constant velocity or a prism velocity here. So what we're going to do is we're actually going to use another custom toolbox. If I go down here to Math and Statistics and grab another custom toolbox, what we need to do to calculate the flow, if we have an acoustic Doppler that's actually measuring our velocity, is we need to multiply the velocity by the cross-sectional area of the flow. So we need to calculate the area of flow based on the depth. And we have a little custom toolbox for doing that. I'm just going to wire in my depth, that's my depth data, into the custom toolbox. We'll go into the custom toolbox and we'll do pipe area from depth. Now again, I'm going to have to go into the properties here and specify 24 inches as the default value is correct here. So I've got a 24-inch pipe. We're going to call this output time series the pipe area, and then we're going to run that. And I'm actually going to see here the output of this is the pipe area. So this is going to be very similar to our pipe depth. It's going to look very similar, but of course now we're in the area of that pipe. So now what we want to do is actually just use a very simple math toolbox, drag it out onto the whiteboard, and all we want to do is multiply our velocity time series, this one right here. We'll bring it down and we'll wire it into the bottom of the math by the area. So this is the area computation right here, and if I wire that into math, let's go into the math toolbox, and the operation we want to do between these two time series is point-by-point multiplication. So I'll just choose that right there, and if I apply that calculation and then I run this computation, the output is going to be my flow, this time calculated using my acoustic Doppler velocity against my pipe area calculation. And of course, I didn't set up my units correctly here. I could have done that properly by going into the math toolbox, and I would have had to drag this up a little bit. We could go into the options and set our output description in units if we wanted to. In this case, once again, it would be cubic inches per second, and the description here is, once again, flow. I could just enter whatever I wanted to there, and if I apply that and run that, once again, our output time series now will have the correct units. So that's really how we can go through and do these sorts of computations in Aquarius. Cubic inches per second, this is my flow. So very easy using custom plug-in toolboxes that you can download from the same site where you're watching this video from. If you're using the support.aquaticinformatics.com site, you can download those custom packages because those are ones we've made available as part of the installation of Aquarius. After the fact, you can just download those if those would be appropriate to your uses.